Okay, welcome back. So in this lesson, I want us to look at another way of writing functions. And so let me create my prototype. So remember, or there's a pattern to this. So the first step is always to create a prototype, function prototype. Okay, so we're telling the compiler what is it exactly that our function will look like, its signature. Okay. Or sometimes called its declaration. Okay, so we're gonna have void, okay, and we're gonna create something called message, a function named message, well, messenger, okay, and this function will accept a, let's say, a string, okay, and let's call this string message. All right, semicolon. So this is just my heads up to the compiler, telling the compiler that I look out for this function. So I will come down here and I will simply say void messenger, and of course I will need to have some variable of type string, and I will call it message. Okay, and so what I will do, okay, I will make an assumption. Okay, so I will make an assumption. So function implementation, or definition. Okay, so I will make an assumption. I will assume that message contains what has been provided to the function. Okay, and so since I assume that message is a string, I can use that inside the body of my function. So I will say cout, and I will have a message followed by an end line. Okay, and that's it. Okay, so let me call this function. So that's step 3. So we call the function. And so to call this function, I will simply say messenger, and I will give it the string hello, hello there. Okay, and then I will put a new line. Notice when we call the function, we don't put any end line. Okay, so we have to put that down here. Okay, so if I run this function or this program, then I will get hello there. Okay, now normally we could do it this way, but what I like to do, because I don't want any magic numbers or magic variables, I will simply create a new string variable, and I will call it maybe message, and I will put the string that I want. So hello there. And this allows me now to remove this hard-coded string and simply put the variable name. Okay, and so to show you that this still works, I will run it. Okay, and it still works. And this is the preferred approach because we are not hard coding the string inside the message, inside the function call. Right? So this is what we do. We create a variable to hold the string, and then we use that variable inside the function. Okay, now another interesting question that you might have is, I am calling this message, I am calling this message, and I am calling this message. And so you might say, well, it seems the name has to be exactly the same. And the answer to that is no. The names do not matter. The names are irrelevant. Okay? What the compiler will do is to see the type string. Okay? It cares about the type string. And to prove that to you, I will remove message from the prototype that we did here. And if I click play, you'll notice that it still works because the compiler does not care about the name of the variable. But humans care, and that's why we put it. Okay. So what about the message name here? Well, I could change it and call it let's call it X. Let's call it X. Okay, just for argument's sake. Of course, I have to call this X. Okay. So does this make a difference? You will see that it does not. Okay. So the name is irrelevant as long as you are consistent with the name, of course. Okay. So why do I use message? Well, because it keeps everything consistent. And so I understand, I can follow the code when I see, oh, okay, message is what we're using. But again, the name does not matter. Likewise, I did not have to call this message. I could have called this X as long as this was called X. Okay, and so you'll notice that it still works. So again, the name does not matter. Okay, for the compiler, that is. For us humans, it makes it easier to read the code. For the compiler, names do not matter. And I will revisit that topic again in an upcoming video, just to show you again that names do not matter to the compiler when we are calling functions. Now, let's save this and let's try it one more time before we wrap up. Great, it still works. So I will leave it here. This is another way of writing a function, but notice it still has the 3 steps in the pattern. Step 1, the prototype. Step 2, the implementation. And step 3, calling the function. Now keep in mind that when you call a function, it must have the same signature. Meaning, if I forgot to pass in something, okay, the compiler will say there is no matching function. Because we have told the compiler that there is one function called messenger which accepts a string. We have this function which accepts a string. But here we are calling a function called messenger that does not accept anything. And so the compiler is telling me that there is no function inside this program that exists currently that is named messenger and does not accept anything. There is none. And so we need to make sure we follow the function signature. Okay? And so the compiler will now not complain anymore. Okay, so let me make a note of that. This function takes one argument. Okay, so argument is just the things that we put inside the function. Okay, concrete things. Hello there, right? That's concrete. All right, we refer to this as argument. You can have one or more arguments. That's okay. Or, as you saw previously, you can have no arguments to a function. Okay, I'll see you in the next lesson where we look at a third. Well, actually, before I do that, Let me stay on the topic of arguments. Let's say I want to print the message multiple times. Well, I could change my signature and I could say that this function will also accept an integer, which I will call count. Okay? And so I have to change my definition to include that new function signature. Okay? Now, what am I going to do with count? I will wrap this inside a for loop. And so I will say for int I is 0, and while I less than count, I will increment I, so by 1. And so what I will do is to print message every time. Now, we fixed the implementation, we've altered the prototype, but notice I have a red mark on line 13 because the compiler is telling me again that I am calling a function called messenger with one argument, but it cannot find a function named messenger with one argument. All it knows about is messenger with 2 arguments. And so I will fix that. So I will simply say int, let's call the variable count. Again, I could have called it anything I wanted, but count seems a good name. And so now I will just put count here. Again, I could have just put 5, but we don't want to hard code. So count. And let's verify this. Okay, it works. It prints hello there 5 times. So that's it. Arguments, you can have one or more, and we must make sure we remain consistent with the actual function signature. 2 arguments, okay, 2 arguments or 2 inputs, let me use that word, 2 inputs, 2 inputs. And so we'll also provide 2 inputs. Of course, we call that arguments. Okay, this function takes 2 arguments, okay, aka inputs. Okay, and this signature it takes 2 parameters, aka inputs. Okay, so this one takes 2 parameters, okay, or inputs. Okay, so this is just a bit of terminology, computer science terminology. When you're declaring the function or the prototype or the signature, the things inside the parenthesis, we call them parameters. Okay, parameters. When you actually call the function and provide it with 2 concrete things, we call those concrete things arguments. Okay? All right, I'll see you in the next lesson.